us out.
Okay.
And this Atul, he took a sabbatical for 6 months from his work
To be
and
here?
he joined the Ashram.
Oh, good.
So he work and this all softwares and whatever is there. So yeah, so these are all the groups. So
I'm very happy to hear you're doing that.
Yeah, thank you. We are really impressed to see you here, and
I mean, I'm very happy to come here because in the city it's noisy and dirty and honking, and you come here and there's trees and a nice breeze, and people are excited by what they're doing. So I'm always happy to come here.
yeah, it's always good to get energy from the people like you.
Good. When communication became digital, an analog telephone was a waveform, and it would degrade with distance. What Claude Shannon showed was if I give you a symbol, the error in decoding it goes down exponentially with the resources representing it. So for a linear increase in the code, there's an exponential reduction in the error. And that's what digital really means.
Okay.
That you can detect and restore state, and there's this exponential reduction in error. So that's what digital computing and communication is. And so 3D printing, like 3D machining, there's no information in the material. If you start a 3D print and it doesn't adhere to the bed, you just get a tangled mess.
Yeah.
Okay? The ribosome is the protein that makes proteins, essentially. And it assembles amino acids with a code, and it detects and corrects errors. So when you copy DNA, the error rate is a part in 10 to the 8 because there's a code in the construction. And so if you think about Lego bricks, Lego is more accurate isn't trash because you can disassemble it. And so the research we're doing on the future of 3D printing essentially is not printing but assembly, where you have discrete parts with codes for their construction. And so in the construction you can detect and correct errors.
Right.
You can join parts from dissimilar materials. The global geometry comes from the local constraints. And you can unbuild as well as build. And so it's based on putting information into the construction of the materials.
Okay.
Which, it's hard to 3D print functional materials. It's hard to reuse 3D prints. Those are all the reasons.
Right.
Okay? And so that's still many years from being ready to use in the field, but we're working on projects like making integrated circuits in a tabletop process, or we're working on making airplanes, and it's all based on assemblers coding the construction of parts.
So part itself will have its itself that my shape is this and kind of.
Well, ultimately, initially, that comes from outside, but ultimately where it gets really interesting is we want to make the assemblers out of the parts they're assembling, so an assembler can assemble an assembler. And that's when then you really get sort of the exponential growth in it. And so that's what I meant by that comment. So in fab labs just all over the world, 3D printers, and once you have all the different machines, 3D printers as you know them today just don't get used that much compared to all the other processes. Like, one of the biggest things not well used here yet that I want to develop here is composites, where instead of printing, you make tooling to lay up fiber composites that let you quickly make large, light, strong structures, in ways that you can print.
I also want to show you the Polycom room.
Okay, yeah.
So every week we meet Neil in this room on Wednesday 7:30. So Pradnya, show him the place.